Hello, year ones. How are you?
Hello, year ones. How are you?
We hope you're well.
We hope you're well.
Welcome to another problem of the week.
Welcome to another problem of the week.
Are you copying me?
Are you copying me?
Stop it.
Stop it.
No, really, stop it.
No, really, stop it.
Enough Tautau.
Enough silliness. What are we learning about today?
Well, today we're learning about sharing. Sharing equally, so taking a whole and then sharing it out equally among a certain number of groups.
Oh, sounds good. Let's begin.
Yes, let's begin. So last week, if you remember, we looked at grouping, which is taking a whole and then making equal groups, so splitting the whole up into equal groups. In this example, there are 8 socks. If I put them into pairs, how many pairs will there be? So we can put them into pairs, into twos. So 1 pair is 2. 2 pairs is 4. 3 pairs is 6. And 4 pairs is 8. And I stop because 8 is my whole. 8 is all of my socks. Then we can say that 8 is divided into groups of 2, and there are 4 groups. We saw that 8 represents the whole, all of the 8 socks we have. The 2 represents the size of each group. There's 2 socks in each group. The 4 represents how many groups there are. So there are how many groups of what in 8? There are 4 groups of 2 in 8. So that's grouping, taking a whole and splitting it up into groups of a particular size. What we're looking at today, sharing equally, it's similar to grouping, but it is different. So a question I want you to be thinking about today is, what's the same and what's different about grouping and sharing? Okay? Now, doing some practice of your counting in 2s, 5s and 10s will be really helpful for our lesson again today, and you should be doing that at home lots anyway. But we're going to get stuck into our sharing equally. Here's our first problem. I have 20 conkers and I share them equally between 5 children. How many conkers does each child get? How would you think about that? How might you do it? And maybe you want to do that at home. You could get 20 of something and then share it out between 5 people, 5 groups. Let's go through it together now. Now, I know you've had lots of experience of sharing things out equally in your life, haven't you? I'm sure you share things all the time. So one way of doing it is the one each method. 1 for you, 1 for you, 1 for you, 1 for you, and 1 for you. And we'll keep going back to the first person. Another 1 for you, another 1 for you, another 1 for you, and so on. And we keep sharing them out one by one until there aren't any left. And we know that everybody will have the same amount. So this is one way of sharing a whole out equally. So let's see. We can see by subitizing, can't we, that each child gets 4 conkers. There's 4 in each of the groups. So we can say each child gets 4 conkers. Or 20 shared equally between 5 equals what? 4. Now let's just pause. What does the 20 represent? The 20 represents the whole, all of our conkers. What does the 5 represent? The 5 represents the number of children that we're sharing between, isn't that right? What does the 4 represent? The 4 represents how many conkers each child gets. Well done, Mr. Morrissey. You solved the problem and worked out the answer. Thank you, Tautau. Just one problem. What's that? I don't like your method. You don't like my method? Why not? Well, let's look at another example and see if the children can spot the problem with your method. Okay then. Here we go. There are 24 beanbags. Can you see the 24 beanbags? If they're shared equally between two teams, how many beanbags does each team get? How would you do this at home? I'm going to use Mr. Morrissey's method. While I'm going through it, I really want you to think about what's not so great about his method. Can you think of a better one? Let's do it. Sharing out one by one until there's no beanbags left, just like we did with the conkers, one each. One for Team A, one for Team B, one for Team A, one for Team B, one for Team A, one for Team B. What are you thinking about this method? Be honest. How are you feeling? Well, isn't it all a bit boring? Time-consuming? This is taking forever. I don't like methods that take a long time. Doing the same thing over and over. I'm thinking, is there a better method? Well, let's think about that. But first, what's the answer? Can you tell me what the answer is? How many beanbags does each team get? What do we need to do to find the answer? We need to count the beanbags in each group, don't we? I'm going to cross out each one as I count because I don't want to count one twice or miss one. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So each team gets 12. So we can represent this as 24 divided between 2. 24 is all of the beanbags shared out equally between two groups. Divided between means shared out. So what's our answer? 24 divided between 2 is equal to how many each? 12 each. Does that make sense? So thinking about a better method, a quicker one, a more reliable one. Any thoughts? Great point, Tautau. I totally agree with you. I don't like methods that take too long. They're boring and it's easy to make a mistake because you can lose track of things. So let's try a different approach. What's different about this time? Here's our new problem. There are 5 balloons. If they're shared equally between 5 children, how many balloons does each child get? How would you think about it? By all means, pause and work it out yourself first. So in our old method, it would have been 1 balloon each. What about this? What did I do differently? And what's the answer? So 1 5 is 1 each, isn't that right? And all our 5 have been shared out. So we're done. And we can just say our answer. 5 shared between 5 is how many each? It's 1 each. Can you see that each child gets 1 balloon? Okay, next one. There are 10 balloons. If they're shared equally between 5 children, how many balloons does each child get? Now, can you use what we did in the last problem to help you with this? Well, I'm going to do it now. Have a look. So we know that 1 5 is 1 each. So we've used up 5 of our 10 balloons. And next step, 2 5s is 2 each. And that's all of our 10 balloons shared out. So we're done. What can we say? 10 shared between 5 is how many each? It's 2 each. So each child gets 2 balloons. Next one, there are 15 balloons. If they are shared equally between 5 children, how many balloons does each child get? How would you do this? How do you think I'm going to do this? Let's start. So, 1 5 is 1 each. That's 5 of our balloons. 2 5s is 2 each. That's 10. 3 5s is 3 each. And that's 15. 15 shared between 5 is how many each? It's 3 each, isn't it? So each child gets 3 balloons. Does that make sense? Can you see how that's much quicker? What am I doing there? That's much, much quicker. One more example. There are 10 children. You can see the 10 children there. They're waiting for their lunch, all very hungry, lots of rumbling tummies. If there are 30 meatballs, how many does each child get? 10 children, 30 meatballs. How would you do it? What would the slow way be? What would the quicker way be? I'm going to do it now. What do you think my first step is? It's pop. We can say 1 10 is 1 each. We've given out 10. 2 10s is 2 each. That's 20. 3 10s is 3 each, and that's 30. And that's all our meatballs. We stop. We've shared out the whole 30. So 30 shared between 10 is how many each? 3 each. So each child gets 3 meatballs. Well done. So remember this problem from earlier and Mr. Morrissey's long, boring method, sharing them out one by one? How did we make our method faster? Well, what did we do? How could we do this in the quicker way? We used a skill we're all very good at now. We used skip counting, didn't we? We're sharing out 20, that's our whole, that's our total. It's between 5, so we skip count in 5s. 1 5 is 5, 2 5s is 10, 3 5s is 15, 4 5s is 20, 5, 10, 15, 20. You can use your skip counting, your counting in 2s, 5s and 10s to help you do these sharing equally problems. You see, everything's connected in mathematics. That's what makes it beautiful. Quite right, Tautau. I totally agree. So we can use skip counting to do these sharing equally problems. Now, here's some problems for you to do to see how well you understand sharing equally. You can choose your favorite method. You can use the 1 by 1 sharing out method, particularly to begin with, if you understand that better. But if you can, try the skip counting method. It is a better method. It's quicker, it's more efficient, and you're less likely to make a mistake. Our first 3 questions here, and it would be a good idea to use objects to help you do the calculations, or pictures as well. And then 2 more challenging problems to get your teeth into. I'd like to get my teeth into those cakes. Answers coming up. Are you ready? So here's my answers to the first 3 questions. For number 3, there are lots of methods. Here's mine. Does it make sense? Box 1, box 2, and then these are counters that I'm sharing out equally. Our problems for the first one, the answer is 16. For the second one, you could also say, the grant is being fair as long as you can explain why. This is only a possible answer.
Well done, year one!
Well done, year ones!
Great work on sharing.
Great work on sharing.
Take care and we'll see you soon.
Take care and we'll see you soon.
Are you copying me?